Welcome, stargazers. Can you believe it? Picture a celestial event so massive that it casts shadows on Earth, visible even in broad daylight. That's the spectacle we might be on the brink of witnessing in the Orion constellation. The star Betelgeuse is acting mysteriously, hinting at an impending supernova explosion that will light up our sky like never before. But when will Betelgeuse go supernova, and what will it look like? According to scientists, what secrets might this stellar event unveil? Join us as we dive deep into the details of what's really going on with Betelgeuse and the impact it might have on Earth, and perhaps for the entire solar system. Located approximately 650 light-years from Earth in the constellation Orion, Betelgeuse is not just any regular star. It's a red supergiant, one of the most luminous stars known to us, shining with a brightness over 100,000 times that of our Sun. But why does this red giant matter so much to us? Well, Betelgeuse stands out not only for its brightness but also for its history and significance in human culture. Named after the Arabic term Yad Allah, which means the hand of Orion, Betelgeuse has been observed and documented by ancient civilizations for centuries. It has been a guide for travelers and a point of wonder for stargazers, with its reddish hue distinguishing it from other stars in the Orion constellation. Can you imagine a single star dwarfing our entire solar system? To provide some perspective on the sheer enormity of Betelgeuse, if it took the place of our Sun, its edges would extend all the way to Jupiter. How can a single star achieve such colossal proportions? At 10 million years old, it's a lot younger than our 5 billion-year-old Sun, but Betelgeuse's massive size means it consumes its materials at a much faster pace, predicting a shorter lifespan than that of other stars. Now, this celestial behemoth, spanning a volume large enough to contain more than 1 billion of our suns, is nearing the end of its life cycle. When stars of such magnitude reach their twilight years, they don't just fade away. They go out with a bang. A supernova explosion that's beyond human comprehension in terms of its energy and brilliance. Such an event has the potential to outshine an entire galaxy, casting shadows of brilliance across vast cosmic distances. The last time Earth witnessed a supernova explosion this close was in 1964, long before the invention of modern telescopes. This event, known as the Kepler supernova, was the last supernova to be observed in our Milky Way galaxy with the naked eye. Visible for over 18 months, it was brighter than any other star in the night sky and even remained visible during the day for several weeks. What mysteries do these stellar remnants reveal to us? Ancient records from various civilizations, including Chinese and European astronomers, documented the appearance of this new star. Intriguingly, remnants of this explosion in the form of an expanding debris cloud can still be observed today with sophisticated telescopes, giving us insights into the violent ends of massive stars. Historically, supernovae have been rare observers on Earth, but imagine for a moment a stellar detonation so intense that it rivals the brightness of a full moon, casting shadows on Earth at night and being visible during daylight. The radiation from such an event would charge our atmosphere, potentially impacting satellite operations and possibly even the climate. Betelgeuse, with its unpredictable dimming patterns, suggests it might be gearing up for just such a grand spectacle. Could we be on the verge of witnessing one of the universe's most dramatic events? Astronomers have made a startling revelation. Between October 2019 and early 2023, Betelgeuse underwent a remarkable transformation that drew the attention of astronomers and enthusiasts worldwide. Known as the Great Dimming, the star's brightness, which had been consistent for centuries, began to decrease significantly. This sudden change was so evident that even casual stargazers noticed it when comparing Betelgeuse to other stars in the Orion constellation. It means that we're not just centuries away from witnessing its supernova explosion, but perhaps mere decades or even less. By April 2023, astronomical observations reported that Betelgeuse had returned to its standard luminosity levels, leading many to believe that the period of anomaly had ended. In a surprising twist, the following months witnessed Betelgeuse's brightness amplifying by an astonishing 50%. Such notable fluctuations, while typical of variable stars, were unusual for a star like Betelgeuse, which had predominantly exhibited predictable luminosity cycles. The sudden and intense surge in its brightness thrust the star back into the spotlight, sparking discussion about its immediate future. But what caused this abrupt change in brightness? Why did Betelgeuse, one of the most familiar stars in our night sky, suddenly throw a celestial curveball? Stars are not merely twinkling dots in our night sky. They are dynamic entities with life cycles, activities, and mysteries of their own. For many celestial bodies, periodic brightness variations can be anticipated, akin to the rhythms of Earth's seasons. Throughout its stellar lifetime, Betelgeuse maintained a fairly consistent 400-day luminosity cycle. However, with the Great Dimming, it seemed to defy its established behavior, challenging our comprehension of the celestial phenomena above. Now, you might be wondering, are we on the verge of a stellar revelation? While the exact reasons for Betelgeuse's irregularities are still under investigation, a compelling theory has emerged. This theory, focusing on stellar activity and mass ejection, presents an intriguing scenario. Picture Betelgeuse as a colossal celestial volcano subtly erupting and expelling a vast amount of its matter into space. Previous observations from the Hubble Space Telescope revealed that Betelgeuse had previously expelled a tremendous amount of its surface material into the cosmos. This expulsion, a monumental event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our moon. Such events can result in the formation of a dense dust cloud around the star, influencing its apparent brightness and temporarily making it more challenging to observe. Then, as this dust began to disperse or was pushed away by the force of the star's radiation pressure, the veil lifted. This could elucidate its subsequent return to regular brightness levels. Either way, these recent events suggest a star that's not finished surprising us. Many speculate that Betelgeuse might be approaching the twilight of its life. A supernova event, an astounding burst of energy that can outshine an entire galaxy, momentarily occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from a neighboring star, or in Betelgeuse's case, it could be from the exhaustion of its nuclear fuel, which cascades its mass into the core, setting the stage for a cataclysmic collapse. But what drives a massive star like Betelgeuse to its demise? Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse kickstart their journey by burning hydrogen in their cores. This initial phase, known as the main sequence stage, lasts for millions of years and forms the backbone of a star's life. As stars run low on hydrogen, they evolve, embracing new energy sources. In the case of Betelgeuse, as the hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence phase to the helium-burning phase is marked by the star's expansion into a red giant. Over time, as helium reserves diminish, the star undergoes further expansion and shifts into other burning phases, each characterized by the fusion of progressively heavier elements. The bigger the star, the quicker these transitions, given the immense gravitational pressures at play. Then comes the climax when iron starts forming at the core. Unlike lighter elements, iron doesn't release energy when fused, so the energy produced isn't enough to resist the star's own crushing gravity. The star balloons in size and creates an implosion, followed by a massive rebound effect resulting in the explosive force of a supernova. So, is Betelgeuse on the brink of an explosive end or just biding its time? Recent research by Japan's Tohoku University suggests that the star might be in its carbon-burning phase right now. Lead researcher Haddock believes that the core might collapse a few decades after its carbon reserves dry up. However, not all scientists agree. Contrasting studies from Hungary's Konkoly Observatory speculate that Betelgeuse is still in the earlier helium-burning stage. The one thing that scientists do agree on, regardless of these debates, is that Betelgeuse is slated to become the Milky Way's next supernova. Yet, pinning down the timing of this event remains a cosmic guessing game, with bets ranging from mere decades to 100,000 years. Amidst these scientific debates and speculations about Betelgeuse's fate, one fact remains unchallenged: the very nature of our observations. When we look up at the starry expanse, there's a subtle paradox we often overlook. This paradox is rooted in the very nature of time and light in our vast cosmos. Stars and celestial bodies are so distant that their light takes a monumental amount of time to reach our eyes. For instance, the speed of light, while being an astounding 186,282 meters per second, still has its constraints. Consequently, the light from remote stars and galaxies takes its sweet time to traverse the vastness of space before it graces our sight. Gazing at Betelgeuse, you're actually witnessing a spectacle from 650 years in the past. To put that in perspective, when this very light embarked on its journey toward Earth, the Renaissance was just dawning, and explorers like Marco Polo were making their mark in history. Every observation we make of Betelgeuse is like looking through a cosmic time capsule, granting us insights into its distant past. And if, for argument's sake, Betelgeuse had already exploded in a magnificent supernova, we'd remain oblivious for another 650 years. So while we discuss and predict its impending supernova, somewhere out in the vast cosmos, this monumental event might have already unfolded. We're just waiting for it to traverse space and time until it reaches our eager telescopes. The recent revelations around Betelgeuse have led to fervent discussions in the astronomical community, with comparisons being drawn to another sensational discovery from earlier this year, SN 2023X. This recently observed supernova occurring in a galaxy neighboring the Milky Way reminded many of the fascinating dynamics and unpredictable nature of the universe. SN 2023X was unique in its own right. Located several million light-years away, it showcased an intense display of brilliance that momentarily outshone its host galaxy. What made it particularly interesting to scientists and casual observers alike was its uncanny resemblance to what many predict will be the fate of Betelgeuse. The spectrum, intensity, and aftermath of the explosion offered a tantalizing glimpse into the processes that these massive stars undergo as they approach the end of their life cycles. For many, SN 2023X served as a preview of if and when Betelgeuse meets its explosive fate. The sequence of events may look similar to what was witnessed with SN 2023X. In addition, the connection between these two celestial events underscores a broader theme about the interconnectedness of our universe. Whether it's a neighboring star like Betelgeuse or a distant supernova such as SN 2023X, these cosmic phenomena remind us of the dynamic and evolving nature of space. Beyond the tangible and scientific, the explosion would have profound effects on human culture. The sky, observed and revered for millennia, would change. This alteration would lead to reflections on impermanence, the vast scales of cosmic time, and our place in the universe. Such cosmic wonders remind us of the ephemerality of existence and our eternal quest to comprehend the great beyonds. As we contemplate the potential supernova of Betelgeuse, it's essential to understand the broader implications for astrophysics and our understanding of stellar life cycles. Supernovae play a crucial role in the cosmos, acting as the universe's recycling mechanism. When a massive star explodes, it disperses heavy elements into space, enriching the interstellar medium with materials necessary for the formation of new stars and planets. This process is fundamental to cosmic evolution, allowing for the birth of future generations of stars that may harbor planets capable of supporting life. Furthermore, the study of supernovae provides astronomers with valuable data on cosmic distances. By observing the brightness and spectral characteristics of these explosions, scientists can gauge their distances and consequently improve our understanding of the expansion of the universe. This research has significant implications for cosmology, particularly in refining measurements of dark energy and the rate at which the universe is expanding. In addition to their scientific significance, the impending explosion of Betelgeuse serves as a reminder of the transient nature of existence. Cultures across the globe have looked to the stars for inspiration, guidance, and reflection. The idea that a star we can see from our backyards might be on the brink of a monumental transformation prompts us to consider our place within the cosmos. It evokes a sense of humility, reminding us that the universe is vast and full of mysteries yet to be unraveled. Moreover, the potential spectacle of a supernova has captured the imaginations of artists, writers, and filmmakers, often serving as a metaphor for change, rebirth, and the cycle of life. The imagery of a star going supernova resonates deeply with themes of destruction and creation, inviting us to ponder our own experiences of transformation. As we await further observations and developments regarding Betelgeuse, we find ourselves at a fascinating intersection of science, culture, and philosophy, one that encourages us to dream bigger and explore deeper into the mysteries of the universe. Each flicker of light, each new discovery, brings us closer to understanding not only the stars above, but also the profound implications they hold for our existence. Whether we are witnessing the end of a giant or preparing for new beginnings, the story of Betelgeuse is a testament to the ever-evolving narrative of the cosmos. A reminder that in the grand tapestry of the universe, everything is interconnected, and every end is but a precursor to a new beginning.